What are the units of K? The units of K?
Yeah, you'll have to figure, you see the units of K will change depending on the rate law. So what you want to do is once you have your rate law, you know what the units of rate will be molarity per second or molarity per minute. And then based on the concentrations, then you can figure what K is going to be. So it's good. It'll change. The units of K will change depending on what the rate is. Okay, so for example, I'm going to put in one more column. So this particular experiment. So 3 experiments were done. Let's compare experiments 1 and 2. So in experiment 1 and 2, the concentration of A remains the same. Concentration of B increases from 1.5 to 2.5. What happens to the rate? It stays the same. So based on experiments 1 and 2, can we figure out the order with respect to A or the order with respect to B? So we can figure out the order with respect to B. Note that if we increase the concentration, the rate stays the same. So that tells us that the order with respect to B must be, who says it's 0 order? Who says it's first order? Who says it's second order? Yes, it's actually, note that here, we change the concentration, rate stays the same. Note, that means the rate with respect to B is 0th order. Okay, so if we have our equation, rate equals K times A to the X power times B to the Y power, Y equals 0. Okay, so if you do that thing we did before, we take the rate of experiment 2 divided by the rate of experiment 1 equals what we had before. What we would see is that, okay, so let's do that. So we have the rate of experiment 2 compared to the rate of experiment 1. Okay, so let's see, that's going to be 3.2 times 10 to the minus 1. Okay, so as we plug in all our numbers, okay, so we can cancel out these things here. Let's see, 2.5 divided by 1.5 is 1 point something, 1 2/3, 1.67. Okay, so we have 1 is equal to 1.67 to the Y power, so we solve for Y, Y has to equal 0. If we do the same thing for 2 other experiments, so let's see. Which experiments do we want to compare to figure out the order with respect to A? Yeah, we can compare experiments 3 and 1. So note that we keep these concentrations the same. We're doubling the concentration of A. When we double the concentration of A, what happens to the rate? It doubles. That means that the order with respect to A must be 1. First order. Because again, we double the concentration, the rate doubles. That means that the order with respect to A must be first order. Okay, so we're going to have a lot of practice doing this in lab, for lab 3. So let's see. On the next slide, okay, so we'll talk about this next week. There's another method to use to figure out the order of the reaction with respect to each reactant. So we'll do this next week. And then we'll do an example problem. This has to do with DNA. We know that DNA is coiled up in that double helix shape. You really want it to stay coiled up most of the time. And then we'll also talk about reaction mechanisms next week, but before we do that, let's take your next quiz. Okay, so in this problem here, these concentrations are in molarity units. Okay, so again, these concentrations for these two columns are in units of molarity. And then the rate here is in